All right, dude, we are live. What's up, guys? This is Dem Keys, and today I'm not really sure what we are doing. I think we're just going to be doing much of what we're not going to be doing too much of anything. We're mostly just going to be chatting about stuff. Uh, at the moment, I am. Oh, here it is. Okay, so the thing is done compiling. Let me just open that up here so you guys can see it. Yeah, I'm I'm just taking a look at a couple of um, Ratatouille examples. Give me a second here. Oh, this one is stuck. Okay. Is it this? Yes. So this is one of the examples. Another example, which I'm gonna have to compile, is oh, we could take a look at the chart example as well. So let's quit this and okay. This is stuck. So I'm gonna use my other system. What was it called? Chart. Okay. So let's try to build that. Yeah. Um yeah, dude. I wasn't sure exactly what I wanted to stream today. We still have to uh wait, why did that what just happened? Oh, okay. Never mind. Yeah. So we still have to finish the what do you call it? The AI agents course, but I don't think we're going to be doing that today. Dude, I really want to make progress with the stream, if that makes sense. Like my first thing is I want to be able to stream more often, right? But one major hurdle that I've kind of identified is um, I'm just not able to do the talking streams past a certain, or I should say, outside of a certain window of opportunity of streaming. And if I miss that window, then that's it. I can't do the talking stream that day. So, in order to be able to do the stream, I want to do I want to introduce TTS. I want to introduce AI voice that I can use. And I've done some research on that. I've spoken about this before, but I'm kind of just like going over it again. I've done research on that after looking at a couple of different options that were available. One that stood out was a model called Kokoro TTS, and it's a pretty decent model. Not only does the model perform well, but it also has a bunch of different options. It has a bunch of different options for different voices and also different languages. It supports a couple of different languages. Now, um, my first objective there with you know building my own TTS system is I need to get this model into Onyx format, which fortunately they do provide you with a sample script that allows you to export the model to the Onyx format. So that shouldn't be too much of an issue. I just need to take the time to, go and do that. Give me a second. Let me open up my stream on my phone so I can see the chat. Okay, yeah. So that's the first thing, right? I need to be able to export the. Hold on. Okay, let's call this temp. I can rename it later. Uh, oh yeah, I was doing this. Just a second. Let me open up my stream and okay, right. So, what was I saying? Okay, so the first thing was not was what is our first objective? Export Kokoro TTS to Onyx. That's simple because they've already provided the script. I just need to see if there's any specific settings that I need to do in order to, you know, export it properly. And then I should be good on that end. So we can then once I've exported this to the Onyx format, we can kind of step outside of the Python the Python domain, let's say. I wasn't sure what word to use. We can step outside of the Python domain after that because we no longer need Python in order to be able to run this model, because we now have this model in the Onyx format, meaning we can very easily just uh, load up and run this model on any platform that supports the Onyx runtime, or well, the specific Onyx runtime that Kokoro TTS requires. We can easily run the model on any of those other platforms. Now, that brings us to our next thing, which is um, which is run Onyx model. Let's say KTTS. Run Kokoro TTS Onyx model in Rust using Onyx runtime. So fortunately, there is a crate available for this, and actually, I think a couple of other crates also support Onyx. I don't know if they ship with their own versions of the Onyx runtime, or if they are meant specifically to export a given model to the Onyx format. But there is a Rust Onyx crate, so I will be using that, and I'll load up the model into that and run it through that. Now, this is all going to be a bare bones Rust application so far, right? After we've gotten the model running and we've managed to, oh yeah, that should be the next thing, right? Simple, simple console app that, why am I writing all this? Test. Well, that's the same as KTTS, or run KTTS Onyx model in Rust using Onyx runtime. So what's the next thing? Once we've tested out this model and we've run it, I think past that point, we need to set up the TUI. What is this? Oh God, what just happened? Oh, okay. What was I supposed to do? Yeah, this. Okay. Past that point, we need to um, set up TUI for app. Okay. Then, after we've set up the TUI, this will be for later on. Set up multi-threading workflow. Actually, okay. No, hold on. No, no, no. Uh, Set up the TUI for the app Um, Set up systems. Let's say that. So, um, what all systems do we need? Because I'm gonna need to sit and design this entire thing, right? What I had in mind initially was that okay, I'll have like a WebSocket server running that's going to receive data, and the data is going to be, I think I decided to call it a TTS packet. um, then that TTS packet will be well, that TTS packet will contain, a bunch of information in it, like timestamp and text, and there's going to be a field for the audio data as well, but it's going to be empty initially. So this packet is going to then be passed over to um, the processing system, or let's call it the TTS system. I should I think I'd written this down somewhere. I don't remember where I wrote this down. Hold on. Was it somewhere here? Yeah, Kokoro TTS. Okay. So input app runs on other laptop. Okay, that makes sense. Stream AI voice app runs on Stream desktop. Okay, I forgot about that. Yes, I forgot about that part. Yeah, I was gonna build this in like three parts. So one part was gonna run on one machine where I was gonna do the input. Another part was gonna run on another machine where the actual processing would happen, because that machine, at least from what I've seen, it tends to have a lot of idle resources, especially when I'm streaming. So we could use that machine's resources. And once it does the processing, it sends that over to the audio and text app. And the audio and text app is what's going to display the uh, the text and play the audio at the same time as well. So I'm gonna need to design a system that does that as well. I need to work on a system that actually, watches over. What am I saying? I need to build a system that makes sure that um, the when the text is being shown, the audio is playing, or rather, the text is only shown as long as that specific audio is playing, and once that is done, then once the audio ends, then the text can end as well. Additionally, I could add in a tiny bit of an animation in there, which would create like a I forgot what you call it, like trailing text, scrolling text kind of thing, like one character at a time kind of effect. I could do that, or I could do a one word kind of effect, or whatever. But yeah, that can be a slight bit of like a dynamic thing going on. Um, yeah, yeah. So okay, here's what I'm thinking, right? I could have this audio and text application as like a green screen app, and it's gonna be, because it's green screen, so you guys won't be able to see the app itself. But then anytime there's text, we'll have like a text box pop up, and the text box is going to show the text, and there's going to be the whole animation and all of that happening, and once it's done, that disappears. So we can have a tiny bit of like a dynamic effect going on there. Okay, keeping this in mind, what should our approach be here? Hold on, there's a bunch of things. Let me just, yeah. So the multi-threading workflow, I don't think I need to set that up because initially I'm just gonna have one. Oh no, you know what? No, no, no. Hold on. I need a multi-threading workflow. Actually, I need to also test out if there is a need for multiple threads, if there is a need for me to set up multiple threads, because I know that the Kokoro TTS, not Kokoro TTS, I know that the Onyx runtime does multi-threading to a certain extent, but how well that multi-threading is gonna suit what I'm trying to do, I don't know. I can't say for sure. Back up. What's going on here? Why is it on this? Okay, let's do that. Give me a second here. Just gonna check something. Yeah. Okay. All right. Okay. So, um, give me a second. Oh damn! Did opening this really like slow things down? I think it did. Yeah. Yeah. I think it did. That's fine. I don't need too much in terms of frames. So let it. In fact, let it show this. Yeah, this can be a nice, I don't know, screensaver kind of thing. But yeah, where was I? Okay, so what was I saying? Yeah, I need to look into how well the multi-threading that the Onyx runtime does, how much it helps. Sorry, zoned out for a second. Yeah, I need to see how much it helps because if if I find that it's more beneficial for me to create multiple threads and spawn jobs in each of those threads, um, then I might just do that. But if I notice that the Onyx runtime is able to handle the multi-threading well by itself, then I don't think I need to do any more multi-threading on my part, because it's not like I have, so many threads anyways. I'm still very limited because my hardware is okay, but it's not like I have so many threads. So yeah, I need to see if the multi-threading that the Onyx runtime is doing is satisfactory or not. Because the multi-threading that the Onyx runtime does is going to be different than what I do. Because the Onyx runtime does a lot more lower level multi-threading, which is actually more beneficial in some cases. Like it does inter-op and intra-op multi-threading, but the multi-threading that I'm going to be doing is basically running the entire model on a separate thread. But then I don't know how. Wait, dude, I think having this website open is slowing things down. Give me a second. Give me a second. Actually, I'm curious. What's that taking? No, it's not. It's not slowing things down. It is not slowing things down. Okay, let's just have this open and let's unload this and yeah. Okay, we can probably unload this as well. All right. Yeah. So I feel like I'm just going in circles now. But yeah, I need to run some tests and see which one is faster, which one performs better. If I find that, you know, multi-threading is helping, or well, my own multi-threading is helping, then I'll do that. I'll set up my own multi-threading workflow. But this also means that I'm going to need to design the system from the beginning, keeping that multi-threading flow in mind, just in case, you know? So I shouldn't assume that I'm only ever going to offload it to one thread. Though, okay, there's another thing to keep in mind. No, 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 no. I was about to say that I should also design it keeping the distributed workflow in mind, but I don't think I need to do that. I need to stop trying to make things scalable and just do the little bit of extra work that it might take to um, fit something to a certain situation rather than, you know, trying to create a one size fits all solution and being like, oh, okay, you can use this for this purpose and that purpose and that purpose and that purpose. But then the majority of the purposes that I designed it for, I just don't end up using it for them. And my effort is kind of like wasted. Okay, okay, right. So, um, right now, I first need to work on exporting the Kokoro TTS model. Okay, that'll be done. Then I need to run the Kokoro TTS model using the Onyx runtime. Um, I can also add another thing, set up audio workflow. Um, yeah, set up audio workflow. Then we set up the TUI for the application. Where does multi-threading come into this? Because once we set up the application, once we set up the TUI, I'm definitely going to need to work on the multi-threading side of things, unless I want to do async, which I believe um, Ratatouille does support that, but like I'm leaning more towards the multi-threading side. The thing is, I haven't really gotten to the multi-threading side yet. We are going to be getting to the multi-threading side. Give me a second. I'm taking a look at the chapters list. So currently we are on traits. After traits, we're going to move on to lifetimes and then closures and iterators and then smart pointers and then concurrency. So I'm still like three whole chapters away. And like in these three chapters, there's going to be quite a lot for me to explore. Actually, I feel like closures and iterators, I might get through it pretty quickly. So I guess that's a plus. Lifetimes, I need to understand exactly. Like I get the idea behind lifetimes. It's more that you need to let the compiler know how long a certain variable, a certain thing is going to be living, and that's why you specify a lifetime. So it makes things a little more deterministic. I forgot where exactly the dyn keyword comes in, because the dyn keyword is used for I think it was called dynamic dispatch, and that is you specifically use that in situations where you don't always know the runtime. You don't always know the type at um, you don't know the type at compile time, but you know the type words, dude. Okay, dyn is used in situations where you do not know what type is going to be used, so you cannot specify a certain concrete data type. You just let the compiler know that okay, this is going to be we'll find out the type for this at runtime. So I don't know where that is going to be covered in this. I think maybe that comes under, I don't think that comes under unsafe rust. I think it might come under smart pointers maybe. Or it could be lifetimes as well. I'm not sure. But yeah, okay. So, um I'm going to need to get through just a second. Yeah. So I'm going to need to get through this. I'm going to need to finish learning multi-threading before I can actually start using multi-threading. We need a couple of systems, right? Oh, in the meantime, actually, once I'm okay, so I also need to learn Ratatouille. I also need to learn how to set up the TUI app. Give me a second here. I need to load something up because I need some background sound. Actually, you know what? Give me a second here. I'm gonna BRB. Okay. All right. So, um, I feel like I need to. I feel like I need to work on this list a little more. Okay, so here we're gonna do learn Ratatouille because that's a requirement here. For the multi-threading workflow, we have to learn multi-threading in Rust specifically. Okay, we can delete this for now. Set up systems. Um, uh, how is this supposed to go? Okay, so we need to create the input application as well, right? So, okay, we can do this. Learn Ratatouille, learn multi-threading, and then let's delete this. Right. So, input. Wait, what was the thing called? There was input app, stream AI voice app, and audio and text app. Okay. Input app, stream AI voice app, and then audio and text app. Okay. So we are gonna have to set up. I think first I can start working on the input app, and then I can work on. Dude, I need to find a way to create a specification for the TTS packet message, which can then be shared amongst all the apps, because the same format needs to be known by all three applications because they're all going to be dealing with the exact same type of packet. So I need to do some research on this. So far, what I have in mind is okay. Wait, look into um, creating s- uh, creating TTS packet spec using no, not cargo files, toml, using toml files or using toml format. Spec needs to be shared amongst all apps. Okay, great. Sorry, I was looking at an email that I got. It was regarding one of the comments that I left. It was an issue that I had created. I think I created. I'm pretty sure I created it. Um, It was an issue that I'd created on the Twitch lib GitHub repo, which is it's basically a C sharp library that allows you to interact with the Twitch API and the various Twitch API services. Like, um, first of all, their Helix endpoint. Then there was the IRC chat stuff. Then there was pub sub and event sub and stuff like that. So basically, it's a library that allows you to interact with the Twitch API. Pretty amazing library. Like I used it quite a lot back when I was doing C sharp stuff. Huge shout out to the devs. Actually, one of the Twitch devs was one of the maintainers, and it probably was started by them. I don't remember exactly. The person's name was, I believe, Swifty Spiffy, and they had been heavily working on this project. But yeah, I just saw somebody posted that okay, once this PR is merged, then that problem should be solved. And I had created that issue um, a year or two ago. I'm not complaining. I'm just mentioning that I'm hold on, I'm trying to find it. Oh yeah, I'd created the issue in on January 6th, 2024. I had created the issue. But yeah, that's cool. Hell yeah. Let's go. Okay. So, look into creating TTS packet spec using the TOML format. Spec needs to be shared amongst all apps. This is important because I remember having this issue back when I was working on my VTuber application, because there were going to be multiple components. So each component needed to know about the format, about the message format. And I didn't have a good way to specify the message format. So now I need to do some research on if there is a more standardized way to specify the format, or specify the spec and have some kind of back-end system do the work to create the code for encoding to that format and decoding from that format. I'm gonna have to have a conversation with Gemini about this because Gemini might have some decent ideas. But yeah, I need to look into that. Then we have the input app, we have the Stream AI voice app, we have the audio and text app. Um, for each of these, I need to work on stuff. So this needs to have TUI. This does not need to be multi-threaded, but this needs to have TUI and WebSockets support, and also, of course, TTS packet spec. And that should be about it, I think. Like each time I type in a message, I can also have like a I can create it like a I can have it be like a chat window kind of thing. There can be a big square on top and a tiny rectangle at the bottom, and I'll basically in the big square I'll show the history of all the messages that have been sent, and the rectangle at the bottom is basically a text box that shows uh, actually no, it's a text box where I type the current message that I'm trying to send. So each time I send the message then gets recorded in the history, and then it's going to show up in that big box above. So it's going to be more or less like a chat room kind of format. Um, Give me a second. Yeah, okay. Um, that should be it, I think, for the input app. Then Stream AI voice app. Hold on. Here. So here we're going to need the TUI. There's going to be a requirement for WebSockets support. Um, I need a system. Okay, input system. We need an input system. Uh, receives, what do you call it? Um, receives TTS packets and queues them for processing. For processing by what should I call the TTS system? Should I just call it TTS system? Or I could call it the audio synthesis system, which I mean, isn't that what's happening? Audio is being synthesized from the text. Oh, I just realized uh audio synthesis system would be AS. Nice. So the TTS packet is going to be processed by the AS. I'm going to stick with that. Audio synthesis system. Uh, so then we have, okay, this is a, nah, it's fine. Um, audio synthesis system receives TTS packet, processes text to audio, or synthesizes text to audio, stores audio data into, actually, we should probably also do a compression step. I feel like there should be a compression step in here, though I don't know if the compression actually takes long enough that I should bother offloading it to a different thread. I don't think we need to. No. I don't think we need to offload it to a different thread. Um, to audio, compresses the audio data, um, writes audio, or well, compressed audio data to TTS packet, and then what happens? Does the same thread then send it over to, because we have to have a separate system to send this over to the audio system. But the audio system is not going to be on this app. It's going to be on the audio and text app. Yeah, okay. Um, and sends TTS packet. Wait, writes it to so and so and sends TTS packet to um, audio and text app using WebSockets. Okay, then we have the audio and text app. This also uses TUI and uses WebSockets, um, green screen, or okay, visuals. Mainly green screen, and then text text box with border, or should it be text label? Whatever. Text box with border appears whenever audio is being played and text is being displayed. Okay, so this is basically just gonna have an audio system. Wait, no, this is quite literally just meant for the audio system. So here, I guess we don't need a separate system, do we? Like the audio app itself is the system. So we can do, okay, receives TTS packet. Oh, we still kind of need an audio system. So we can call it the playback system, I guess. Receive TTS packet and queue it up to be processed by playback system. Playback system. Read timestamp. Oh, read TTS packet. Read timestamp to make sure message plays at accurate time intervals or interval. No, to ensure message playback. No, wait. Read timestamp. Um, try to play. No. The idea is to try and play and display messages in similar manner to um, okay, what I'm trying to say here is that I want to try and replicate the timing. Oh, okay. Um, the idea is to try and play and display messages. Now, hold on, dude. I don't know how well this is gonna work because the idea is to try and um, mimic the timing between multiple messages. How should I put this into words? Because what I'm trying to do is, hold on, try and mimic the timing between multiple messages. So if MSG01 is sent and MSG02 is sent 10 seconds later, the playback and display of the messages should reflect that timing difference. Okay, so we read the timestamp. We also read the audio data. Oh yeah, we need to, yeah, read and decompress audio data, and then play audio and display text at the same time. Optional. Oh, actually, wait. No, here I need to make the design choice. Like, should I have it be okay? No, you know what? For now, for the sake of not complicating things, what we can do is we can just display the entire thing at once. Play audio and text at the same time. Text remains on screen as long as audio is playing. As long as audio for that text is playing. Okay, so then that becomes our playback system. And then we are officially done. Okay, now once I've set up this application, yeah, it's kind of interesting because when I was thinking about this idea, what I had in mind was that I was gonna run this entire application, that being the Stream AI voice app, along with the audio and text app, as one app. Like they were not going to be two separate applications; they were going to be the same app. And I was going to run it on my streaming laptop, the laptop that I'm currently streaming off of. But then I realized that my other machine is basically idle during this time. Uh, Just a second here. Okay, I need to do something after which I can. Yeah, I guess we're good. So here's my B top, and in my, oh wait, you guys can't see. I just realized the green screen. Oh yeah, yeah, you guys can't see it that well. I'm not sure how. Hold on. Let me see what you guys are seeing. Okay. Yeah. So B top is. Oh, maybe I can change the colors temporarily so you guys can then see. Um, how does grayscale look? Now you guys can see it, I guess. Yeah, yeah. I guess you can see it now. Give me a second. Yeah, it looks like shit, to be honest. I don't really look at the colors like this. I usually have it in like a different color scheme, but in that color scheme, the green is getting green screened out because I have the chroma key thing set up. But yeah, on the left side, you can see. I don't know why I was going through all this effort just to show this. You guys could have looked at um, the numbers as well. So I have a good like extra 5 GB, six GB free on this machine right now. And even though it is currently streaming, hold on. Right. Yeah, I have a good like 6 GB free on this machine right now. Not the machine that I'm streaming to Twitch from. The machine from which I'm streaming an RTMP feed, that's my Linux machine. The machine from which I'm streaming an RTMP feed over to my main streaming laptop. On that machine, I currently have 6 GB of RAM free. And even though there is an OBS instance running, which is currently, streaming the RTMP feed, each of the cores is only using like anywhere between 10 to 15%, or each of the cores is only being used anywhere between 10 to 15%. So I kind of feel like I could get away with running the TTS system on this machine instead of trying to run it on my laptop, where, the laptop that I'm currently streaming to Twitch from. Um, that's why I decided to break up the Stream AI voice app into Stream AI voice app and text and audio app, or audio and text app. And that's why we are here. So the audio and text app is what's going to be running on my streaming laptop, because all that's going to be doing is processing the TTS packets, which shouldn't be too heavy, and then it's going to play them through some kind of audio library. It's going to play the audio data through some kind of audio library. So all of that shouldn't be very heavy. I am gonna have to see if I still need to do multi-threading in this case, because like I don't know how that system would work. Like if I have WebSockets set up, I don't know if WebSockets is running, if the WebSocket server is meant to be running on a different thread. Um, yeah, I'm gonna have to look into that, because I need to make sure that the applications are never ever blocking. In the case of the input app, it shouldn't be too much of an issue, because it's just, packaging up the data and then sending it, and then that's that. It's never receiving anything. It's mainly only sending. And then we have this main application where I'm probably gonna have to do um, either only multi-threading or a mix of async and multi-threading. So I might need to use Tokyo for that. And then, of course, here we have this as well, the audio and text app, which also requires WebSockets. So it's going to be receiving the data. Uh, yeah, maybe I should have a separate system here for just receiving data as well. Yeah, yeah. Because like, okay, I need to think about it in this way. Um, so the idea is, oh yes, yes. Okay, this is important. This is very important. Um, this part is very important because it needs to be able to. It needs to. So okay, I had this. I don't know if I should call it efficiency plan, optimization plan. What I was going to do is the TTS packet was going to have an index along with the timestamp. I literally just remembered that. Look into creating spec. So I guess let's create the spec itself, right? TTS packet, what is this? Yeah, TTS packet spec. Let's, okay, what just happened? Oh, yeah, okay, okay. I'm not sure what's going on here. So what I'm gonna do is just create the thing here. Look into creating. I'm kind of confused about why this is happening. Hold on, just a second. So we can yank this from here and then paste it, right? It gets pasted as a child of the thing, and then we can undo it. I'm not able to do the same thing here though. Um, and I'm curious about why that is because here I'm doing, okay. Yeah, I think I think it's to do with the clipboard thing that I've set up in on this machine. Uh, I think it's a setting that I've done in Tmux. Yeah, okay, okay, whatever. Look into creating TTS packet spec using TOML format. Spec needs to be shared amongst all apps. Right. Yeah, I'm not sure why that's not. I think I might have an idea why that's not working, but because it works on my other machine when I'm doing it outside of the outside of Tmux, but right now I'm within Tmux, so um, Yeah. Okay. Anyways, TTS packet spec. Look into creating. Okay. And then here I can create the spec itself. It's going to be index, packet index, timestamp, and then text, and then give me a second here. Okay. What else? Yeah, audio data. That's it. I think that's it. It's just supposed to it's just supposed to have these four fields. I think this can be changed. Okay, that's fine. Packet index, timestamp, text, and audio data. So something we could keep in mind here. Oh, oh, yes. Okay, that's why we needed. Okay, yeah, yeah, yeah. Hold up, hold up. Uh, processing system. Okay, in the processing system, we read the TTS packet, we read timestamp. I'm going to need to copy that whole thing over later on. Um, then we read and decompress audio data. And yeah, then we can remove it from here. Wait, I'm curious. Oh, counter open display null. Yeah, I think this is a tmux thing. It's actually it could be a tmux slash SSH thing. I can't say for sure. I'm gonna need to look into this. But yeah, that's a it's a small thing. It's not a very big issue. I've had to deal with a similar thing in NeoVim as well, and I think I had to deal with a similar thing in the Kitty terminal as well. Just in general, there was a setting that I had to. Anyways, uh, the idea is to try and mimic. Actually, why? Hold on, just a second. I'm gonna save this here, okay? And what is this called? Stream mind map. Okay, that's open. Okay, this and this. Okay, yank it from here, paste it here, delete. Yep, there it is. Save, quit, and come back here. Okay, we should be good now. Uh, Here we have this processing system, playback system. I guess I might need to add in an input system as well. If everything is running like on different threads, then we probably need to create a separate system for that as well. That might be a good idea. Create a separate thread and just have the thing running by itself so it can continuously keep receiving data. Oh, I need to also see if audio playback can actually be done from a different thread. I don't know if that's because like I don't know if input output if IO is actually possible through like a separate thread. I have no idea. I'm gonna have to look into that. But yeah, this is what I was trying to do. I was just trying to move read timestamp over to here. We also need the index, and this can be changed to processing system. Okay, play audio and display. Okay, queue up TTS packet um, to be processed. Actually, no, hold on. What what exactly is the processing system doing then? Oh, okay, okay. Keep track of indices whenever the correct index is received, the correct not correct index. Hold on. Just a second. Okay. So, um how should I describe this? Oh, okay. Yeah. TTS packets can be received in any order, but we want to make sure that um they are played in the correct order. So after a TTS packet has been processed, only queue it up for processing by... Actually, okay, hold on. Is all of this really necessary? Yeah, it's necessary because the thing has to be decompressed, and then we just hold on to it until the other message arrives. And this is going to be the case when we have... Wait, I'll come back to this. So in here, okay, so this writes a compressed so and so and sends TTS packet to audio. Wait, isn't there supposed to be a sending system? Like how... um no, I need to see if WebSockets is thread safe. So then maybe I can use the same client to send the message. Actually, let me look that up. Oh, wait a minute. Rust does have this concept of like what do you call it? In concurrency, it has the concept of shared state. So maybe I can share states between threads, and I can easily send something from a worker thread back to the main thread to be, sent by the WebSocket. Or, well, I could have a separate thread uh, for like the sender, the WebSocket sender client. Um, Sender system. Sends TTS packets to audio and text app using WebSockets. Right here, I need to and sends it to sender system. Or I should say queues it up for processing by or for. In? What's the... By? Okay. Processing by sender system. The sender system sends the TTS packets. Okay, fine. Great. TTS packets can be received in any order, but we want to make sure that they are played in the correct order. So after a TTS packet is processed, only queue it up for processing by the playback system if its index is. Oh, dude, no, hold on. I'm gonna need to work on this, on the logic that's gonna be followed here. Yeah, dude, I need to work on the logic here because it's gonna be, in order to maintain that sort of the linear, the ordered nature of it. It's gonna be like, okay, let's say we recently played packet or processed packet number 4, right? So next we are expecting packet number 5, but packet number 5 happened to be big. And so its processing took some time, and so it hasn't arrived yet. But before that, packet number 6 arrived. And we managed to process it in the processing system as well. However, in the processing system, we have made note that, yeah, the previous packet was packet number 4. So we should now be processing packet number 5 instead. Okay. Yeah, you know what? The decompression, I think the decompression should happen as soon as the packet is received. Yeah, I think the decompression should happen as soon as the packet is received. And no, when should it happen? Hold that thought. Workflow. Um Actually, I could have like a, for receiving, I could just have um a WebSocket server running. I don't need to create a separate system for that, right? And each time that server receives a TTS packet, it basically queues it up for processing by the processing system, right? Then the processing system receives it and immediately decompresses the data because the data has already been received. Right. Okay. Okay. Um, receive TTS packet, process packet, no, decompress audio data in packet. And then what happens? Yeah, I feel like there has to be some kind of trigger, and I think that should be in the playback system because the playback system is going to be it's going to have like a time based thing, right? Where it's constantly checking the time of the packets, or well, the timestamps, in order to make sure that it's able to respect the time interval between different messages. Yeah, I need to uh, think about this a little more, but I like where I'm going with this, and it's kind of funny that I was supposed to, like, this was supposed to be our list, like, do this export and learn this, learn that, but then we went into all this, which is good because this is exactly what I'm planning on doing now. Holy shit. Uh I feel like if I'm going to be making this a multi-threaded system, then I need to I need to create a sort of dispatching system, or actually we have like the shared state thing, right? So maybe each of the worker threads can mention their state, and then anytime I receive an input message, I can just check all of those states, and whichever worker thread is currently available, we just dispatch the work to that. Yeah, we could do that, but I need to keep in mind that this has to be, yeah, note, design this to have, or design this with multiple worker threads in mind. Okay, yeah, yeah, dude. Yeah, I think that's gonna be it for today's stream. I started the stream a little late, unfortunately. Otherwise, I would have gone a little longer. I'm gonna right now. I need to rush and finish learning my Rust thing, and then I can proceed with learning Ratatouille and building all the stuff that I want to build. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.